Hello, George Romanic here. Welcome to Fundamentals of Weather and Climate playlist. In today's video we are going to talk about temperature layers in our atmosphere. Please keep in mind that I already have two videos on this topic, but they are a little bit more advanced than today's video. So if you want to know more details about this topic, quantitative assessment, rate of change, gradients of temperature and so on, perhaps watch those videos. Today we are keeping things at fundamental level. I would like to start this video by saying that average temperature globally on this planet is 15 degrees Celsius. And if we start with that value, then in the first layer of the atmosphere that we call troposphere, temperature is on average decreasing with height. And the rate of decrease is 6.5 degrees Celsius per each kilometer of altitude. That to large extent explains why mountain tops are overall colder than the base of the mountain. Sometimes, we will learn later in this course, temperature can even increase with the height, but that's not average condition. And the condition when temperature increases with the height is known as temperature inversion. At the top of the troposphere, temperature is approximately negative 56 or so degrees Celsius, and top of the troposphere is called tropopause. It separates troposphere from stratosphere. Commercial flights are approximately at the height of the tropopause, which is 11-12 kilometers in mid-latitudes. In tropical regions it is about 18 kilometers, and polar regions tropopause is about 8-9 kilometers. That is because pressure decreases much faster in cold air than in warm air, as we will learn later in this playlist. All weather that is of importance for us living on Earth's surface is happening in the troposphere. Thunderstorms, clouds, tornadoes, precipitation, cyclones, anticyclones, all that is happening in the troposphere. Then the next question is, why is temperature decreasing with the height in the troposphere? Well, the reason is, as we will learn later on this channel, atmosphere is predominantly heated by underlying surface. Most of the solar radiation passes through the troposphere and then it is absorbed by Earth's surface. And then Earth's surface is heating up the atmosphere. So consequently, the further we are from the source of heat, namely Earth's surface, the colder it gets. And that's the reason for this overall negative trend of temperature with the height. In stratosphere, temperature is first a little bit constant with height, and then it increases with height. So stratosphere, we would say, is entire layer of temperature inversion. Temperature is increasing with height here because we have ozone, O3, gas that absorbs between 97 and 99% of ultraviolet radiation and consequently increases the temperature of this layer. Maximum concentration of ozone is about 25-28 kilometers above Earth's surface. Some of the modern military aircraft can reach 20-something kilometers, but they are defeated by meteorological balloons that can reach all the way up to 38 kilometers above Earth's surface. At the top of the stratosphere we have stratopause, separating stratosphere and mesosphere. Temperature at the level of the stratopause is almost zero, a little bit below zero. So in terms of temperature you could survive over there. But as you know from my previous video, pressure at this level is so low, about 10 millibars, so you would definitely not be able to survive in such a low pressure environment. You will also remember that at this height, pressure, namely 37-38 kilometers, pressure is approximately the value of the pressure at the surface of the Mars, which is 7 millibars. And then after stratopause, we go into mesosphere. In mesosphere, temperature once again decreases with the height, and that is because the concentration of ozone is low and we are far away from the source of heating, namely surface, so temperature decreases with the height. In mesosphere, most meteors that enter Earth's atmosphere burn, and some of the bigger one might reach stratosphere, then they would burn there, and the biggest one, unfortunately, can even reach troposphere and Earth's surface. That happened some 60-65 million years ago when huge asteroid hit Earth somewhere close to Yucatan Peninsula in Central America and caused devastation to living organisms at that time, and that was associated with the extinction of dinosaurs, as you know. Then above Mesosphere we have mesopause, separating Mesosphere and thermosphere, and that is at the height of approximately 82-83 kilometers. Temperatures here are very, very low, approximately negative 86, 87, 88. And this is the coldest place in our atmosphere. Above mesopause we have thermosphere, and thermosphere is again a layer where temperature tends to increase with the height, but that is because here air is so rare that we cannot talk about atmosphere in a sense we think about atmosphere around us. Here there are only few atoms of air roaming around, so if it happens that that particular atom absorbs solar radiation, it has very high energy, and we know that energy is associated with temperature. So these individual atoms have very high temperature because they have very high energy. But there are only few of them. So if you would find yourself over here, temperature, quote, could be very high, maybe 1000 degrees Celsius, but you would freeze to death because that high temperature is carried, so to speak, by only small amount of atoms that are finding themselves there. So only few of these atoms would hit your body and you would freeze to death because you would radiate out all your heat through radiation. Thermosphere is the part of the atmosphere where we have beautiful aurora borealis, which will be a separate lecture in this playlist. This is also where International Space Station is orbiting around, if I remember, 420 kilometers or so above Earth's surface. And I didn't indicate here, but thermosphere ends approximately at 500 kilometers above Earth's surface. And then from approximately 500 kilometers to 10,000 kilometers or so, we have exosphere, not indicated here. Exosphere has nothing special about it, except that it's a region where atoms of atmosphere escape gravitational pull of Earth and go into outer space. It is very important to understand that atmosphere does not have solid boundary. There is no boundary that we would say right there atmosphere end. It's a blending region between atmosphere and the outer space, and that blending region is exosphere. Anything else of interest to mention here? Let me think. Well, that's pretty much all. I could talk much more about it, but you can see that in stratosphere, mesosphere and so on, there are different rates of increase and decrease of temperature with height. If you want to know these numbers, please watch my video on the standard atmosphere. I explain that in great details. In the next video, we are going to talk about ionosphere. Until then, goodbye.